All right, so this is second module of week 6. So second module is forming processes. So this is second chapter of unit 4. So we are here forming process. In the previous lecture, we saw the casting and molding processes, and then this is forming processes. So this is the secondary manufacturing process. So forming is one of the oldest methods to form certain products. So we are looking at how people develop this forming processes, and then what kind of forming processes exist, and then what are the common practices of the forming process. So I have four objectives. And first one is list three essential elements that must be presented in order to forming process. So we'll talk about the three essential elements of forming process. And then I want to let you identify for the various types of shaping devices used in forming processes. So there's certain shaping devices such as called die or other devices, and then explain why temperature of material is important. So temperature is important in material processing, particularly in forming. So this third objective, and then next one is name and describe three types of forming forces, and then those are keywords. So bending force, cold forming, die, and drawing, drop forging, fracture point, hot forming, and yield point. These are keywords. So I'm going to explain those keywords in the lectures. So this is first we'll look at the how human developed the forming method. So the forming method is using melted metal and pour into the mold and hammer the material into new shapes. So the forming is mostly like about the hammering or creating the material using the mold, right? This is forming. So and the forming change size and shape of the base material. So we have a certain amount of raw material, and then we convert this material using such, for example, like die. So we saw die cast. So this is the cast mold, and then we pour the raw material into the mold, and then we get this product. But the principle of this one, forming is the size and shape it can change, but there is no weight of loss. The raw material and then the final product should be the same. So that means the forming is only for about changing size and shape of the base material. It can be happen like a weight of loss by drying moisture or certain other like minor weight change, but the basically the weight should be the same. And the development of the forming that starts from Bronze Age, like for creating hunting weapon or cooking wares. And then this method also, this is a very traditional like forming method, like hammering to produce certain material. And then also New World settlers make the product using blacksmiths or wagon tire, chain, horseshoes, and then later we developed the rolling and drawing method. So I'm going to explain this method further in this lecture. So before we learn about forming techniques, so there's the essential principle behind this forming, that is this graph. So we looked at this graph in the week four. So that this graph, name of this graph is stress, strain diagram. So that shows the rate of stress and strain. So this area is stress and this area is strain. So stress means the pound per square inch. So if we have a object, for example, and we stretch this object, that means we pushing stress into this object, right? That's the stress. And then strain is inch per inch. So strain means if we stretch this object, that object become like longer, and then that means stretched. So the change of the object or shapes of object, that is stretch. So this diagram shows the materials stress and strain relationships. So in this graph, all material, particularly metal types of metal groups materials, has certain range. First one is elastic range, elastic stages. So at the beginning, we start giving stress to the object. Then, like stretch example, once we stretch the object, that change its like shapes, like this. With the stress, it change uh, this shapes like strain. So this amount of the object changed while putting this amount of stress. That's this graph says. But at some point, the change stop. So that is yield point. Not stop, but this is a certain point. So yield point means that when we stretch this object, and then we just remove the stress, then tend to come back to the original shape. That's the elastic range, elastic stage. So this is the example of the clay. So we feel like try to stretch clay, and then the at a certain range we just remove the stress, then come back to the original side. That's the elastic stage. So certain materials such as copper has a high elastic stage, longer elastic stage, but the cast iron has very short elastic stage. So it depends on yield point. And then after yield point, the object change permanently. That is the plastic range. The material part start give it stress and permanently stretch into new shape and change until a fracture point, until like break out. So these area is so important when we form a object, because this range is our forming range. So when you change certain object, we work in this range, right? So we use this range, plastic range deformation. That's the principles of forming process. All right, there are three forming practices. So for the forming practices, the three are essential. So for the forming, we need to have a shaping device, and then second, appropriate material temperature, and then third one is sufficient forming force. Those are three elements. To make a certain shapes, we need this shaping device. So for example, I want to make a this types of object. We need to have a shaping device. For example, like we need to have like mold, like this type of mold to make this shapes. This could be shaping device. And then to make a permanent change of this our object, we need to have certain temperature, and then we also push certain sufficient force. That's these three elements, right? So about the shaping devices, there are certain shaping devices. So shaping devices are machine or tools used to determine the final shapes of part or product. So similar job is mold in casting, but there are two major types of shaping devices. One is dies and rolls. So die is the similar to the die play the similar role in the die casting. So this is an example of die. So so um, so when we when we want to create these shapes, we need to have the tool like that has the same shapes with the final product. This is die. And then second is roll. So this is an example of the roll production. So rolling die create the certain patterns of a product. That is the two major types of shaping devices: dies and rolls. So let's look at the details of dies. So die is shaping devices. Sorry, dies are shaping devices, which materials is squeezed between or formed over to achieve a new shape. So in dies, there are three types of the dies. So first one is open die, and made die, and shaped die. There are three major types of dies. So first one is open dies. Open dies consist of two flat die hubs. So this is the this is an example of open die. So flat face or almost flat. So this is open die, and used mostly for large objects and smaller quantity, and then only for simple shapes for it, and because it has less dimensional accuracy. So the accuracy is determined by the force of this die pushing this upper die or lower die. That depends on this force of upper die, the accuracy. So this only for simple shapes like this shape. So this is one example of open die forging. So this is the original object, right? And this is die. So while rolling this object, die push this object and create this the pattern, like this pattern. So this is final product. This is example of open dies. But this is not less dimensional, provide less dimensional accuracy. The second type is mated die. So this is example of mated die. This could be bottom, this could be top. So we can put a object between two on top and bottom dies, and they create our desired object. So mated die is a set of die with raised shape on the one die and then matching cavity in other. So material is usually squeezed between the two to take the desired shapes. So mated die can be used to form metals, ceramic, and plastics. And then for mated die, we use forging method. So there are some other types of forging methods. So forging is a manufacturing technique. They used to shape metal using compressive force. So as I mentioned, there are two types of forging methods. The first one is drop forging. So I prepared this example. So All right, in this example, this person is creating a stick. I don't know exactly what it is, but yeah, this is boat nail. They're making boat nail. So you're putting a object into this machine that I'm sorry, put force into this object by dropping a object. So they create high speed force. So that's drop forging, right? So see, this is the red color because that is already heated. So it has high temperature, and in the high temperature, they put the high dropping forging into the object. And then second method is pressing. So pressing is similar to dropping forging, but this is more pressing means like push the object. So the press. So let's just say this is the object, and there's a dies, two dies, but the using the high pressure fluid that push press this one, and then slowly make it the object. That's the press forging. So comparing with the drop forging, the press forging has high productivity or greater accuracy and automatic control. That is a press forging. But the press forging needs a machine that has a high pressure fluid, and then it also has control this process, and then to control the accuracy. That's why this press forging is more expensive and more advanced. And then the third one is shaped dies. So that has only one open piece shaped die. So this is very interesting. So let's look at this example first. This is a shaped die example. You want to create a mask like this. All right, so this is interesting method. So this is also a common plastic forming method. So the principle is using a plastic sheet and a heated sheet, and then we have mold, and then the method is there are different methods, but this example shows a air vacuum. So using the vacuum, we suck uh, the air, and then air comes out, and then the mold goes to inside. So the outer side has a atmospheric pressure. The inside is high pressure. So it make stick to this mold. That is the example of shaped die method. But this example also has the opposite, like the mold. It could be also possible. Like our mold is the like mask. This is nose and this is eyes. This is a mask. We want to make this. If we want to make this object, we can prepare a thin plastic film, and then this while heating, push this object to upside, and then create this shape onto this shape. This shaped die. And then the second shaping device second type of shaping device is rolls. So this is a shaping device. The rolling is very simple. So by rolling a roll, and this is a object. So this is rotating, and then that is pressed. The material object is pressed, and then create a certain shape. So in most case, the roll create a metal sheet. So let's just say I have a this object, and then we have 3 rollers, and then we push this object into the between the rollers. Rollers are rotating. That made like thin metal sheet. So that's the common process of rolls. So there are 2 types of rolls: those smooth rolls or shaped rolls. So as you can see on the name, smooth rolls create a soft, just only make a desired thickness during the primary process, and then shaped roll has a certain pattern or grooves, so that creates a certain pattern on the metal sheet. And then the next element is materials temperatures. So temperature determine is internal structure of the object. So there are 2 types of forming method in terms of temperature. First one is hot forming, and the second is cold forming. So the metal usually goes through several stages of they are heated. So first metal form a crystal structure, and then develop internal stress with the crystal structure. That's the process. So let's just say this is the metal, molten metal, and then while it's solidifying, it start creating certain crystal structure like this. It could be random, or it's a certain pattern, like crystal structure. Start creating a structure, and then next, after more solidified, they start creating internal structure like this. Right, this is the metal structure that become this object, this kind of pattern. So this is the developing process. So yeah, this is the metal solidifying process. But let's look at the 2 differences of forming process, hot and cold. So let's just say this is rolling, and this is a hot process, meaning that we treat high temperature into this object. So this is the original structure, like this, old grain structure, like has a certain grain structure, right? This structure determine the property of this object. So in the high temperature, when we push the rolling, that create a new structure, new crystal structure. So in the high temperature, when we roll the object, then the object create a new structure. So that's the kind of rotating this process, right? This process. So it has new structure, new crystal structure that could be more soft. In this example, this is hot forming, but cold forming. Let's look at here. They already has a certain structure, but the structure doesn't change. The only this by rolling, the structure is squeezed, like stretched. So that's it. That's the cold working. So that doesn't change the internal structure. So And then after this, cold working, in general, cold working product can be more hard, more brittle, while cold forming become more soft. So there's this the two differences, right? So I compared the two process. So hot forming process produce a surface scale, like surface scale, and require low pressure and does not change the properties, right? The properties doesn't change, only change its because it create a new crystal structure. So it doesn't change the property; it's the same because it changes new grain. But cold forming produce smooth and oxide-free surface and require heavier force to make change the force rather than more than the hot forming, and improves strength property, so it become more harder, so that increase strength and create stress that become brittle, the cold working product, and increase hardness. This is this difference between hot forming and cold forming. So yeah, it depends on this our final product. So we can choose hot or cold forming, but the temperature determines its property. And there are three types of forming forces. It's the same as the general forces in physics. So first one is squeezing, and second is drawing, and then bending. So I just prepared this slide for this illustration. So squeezing is pushing, like compressing force, and then drawing is drawing to the outer side, that is stretching, and then third one is bending. So those are three types of forces in the forming process. So the first example, squeeze compress force, is used in the die processing. So this is a die processing. So this is plunger, and we already poured the molten metal, and then push that squeeze and create our final product. That could be wire or certain product, depending on this die. This die create a shapes. So this is the example of the squeeze force. And then second example is the drawing stretch. It's a deep drawing. So deep drawing is very common, very popular method. So this deep drawing method create this kind of sink or aluminum can, right? Aluminum can as the aluminum can. This example shows the aluminum can. So you start from a aluminum sheet, and then as punch, you push down, and that stretch this part, right? This part is stretched, so it make this shape. So this surface are stretched by pushing this force. So that, and then it create certain shapes that could be aluminum can, or aluminum can also mostly created by this deep drawing using stretch force, right? And then third is also bending. Bending is so simple. All right, so this will be the last one. So source of forming pressure. So we use the certain forming pressures, so such as hammer or press, rolling mill, and draw benches. So those are graphical illustration of four, like hammering. So we can do like hand hammer or machine hammer, such as impact drive, and then press also use this continuous drive. So press can be used by hydraulic force. As also this is a draw bench that this is this draw bench is to create a wire, a thin wire, so that with a die that draw this object, then create a thin wires. Also rolling mill also creates wires. So those are sources of forming pressures. All right, so this lecture illustrated about the forming method. So I'm going to quick summary. So I present the four objectives. So the first one, what are the three elements for forming processes? So first one, we need to have shaping devices such as die or rolls, and then second is appropriate material temperature. It depends on the material's melting point or that its forming range. And the third one is a sufficient forming force. These are three elements. And then three types of shaping dies. There's three types of shaping dies: open die, mated die, and shaped die. And then temperature has a big influence on the forming operation because in the high temperature that change the material's property because by creating new crystal, but the lower temperature that doesn't change the properties, so that change the strength. So in the cold working, after cold working, that the objects become more harder or increase strength. And then the name of three types of forming forces were the squeeze and stretch and then bending. All right, so this week we had many concepts and many graphical illustrations, but I want to you enjoy this lecture. Also, you have some knowledge about the manufactured product, how they were produced. All right, so I prepared the second quiz, and then we'll review these concepts in our synchronous class. Thank you for watching.